Hello and welcome to High Fell, and things are not good. This is Silver King, which managed about 32 hours and then the motor failed. And this is a bit of an issue with these 3-pole motors were fitted in the original TT 120 locos. It's not purely a Hornby issue. These type of motors are problematic. Even though this loco was out of warranty, Hornby took the loco back and have fitted a new motor. However, it works, but only in a sort of a fashion. So I've already done a scale speed calculation, and this loco can manage 71 miles an hour at a full CV value of 255 and on 126 speed steps, which is the maximum you get on the most DCC controllers, even though it says 128. So I'm just going to show you, and I don't run my locos like this normally, but I'm going to give it a full high speed run, and then you can see and also hear the motor hopefully. So that's full speed. And normally these locos run way too fast. So I'll just pull that back down. So you can hear the motor is excessively noisy, and it is also, I'd say, too slow. It's struggling to get anything like its scale speed. I normally calibrate my locos to like an A4, probably run about 100 miles an hour, because that's really the speed that they tended to do maximum. I'm also now going to show you in reverse as well. In fact, the noise it makes in reverse is even more horrific. But when it gets here, I'm only running it slow, so I can't complain on that. And really what we're going to look at is the slow speed running. Now I hope the camera's going to pick that up. It's quite inconsistent, very notchy. You see it, but then listen as it slows down. My goodness, what is that? Well, I have a feeling I know what that is. So what I'm going to do now is I'm going to take the loco off. I actually have got some replacement motors. I have previously done on another motor that failed. I've done a brush swap, so I bought some cheap motors off eBay, which are N20, that's the dimensions, and I've swapped over the brush section. Now, traditionally, we probably would remember things like model locomotives having these small carbon brushes in, which was the way it was always done. They were serviceable, etc. Now with can motors, they have what are basically referred to as a precious metal brush. And I'll show you what that looks like. It has no carbon on it, and the problem is they basically eat themselves. And I think that's what the sound is that's coming from this. Bear in mind, this has probably run for about 20 minutes, having had a brand new motor fitted. So I'm going to get into that. I'm going to show you also how you, for anybody that doesn't know how you do it, how you strip down an A4. It's a little bit different, and it's got something which isn't covered in the instructions, so I'll show you how you do that. I'm going to try and do this in big sections, so you can see there's no jiggery pokery, there's nothing being taken out, there's no sort of clever editing, anything like that. It's just really as it is, and this is not meant as a video to basically sort of do any blaming or anything. These motors are problematic, and there's some very good reasons why these motors are chosen, but there are also a couple of downsides, and we'll get into that. And hopefully people will see that there are options to fix it yourself, and hopefully Hornby are actually working on a more long-term fix, or certainly a viable way of us ensuring our models keep running for a respectable amount of time. So over to the table. So here we are back on the table, and just going to show you, first of all, this is the type of motor. This is not an exact one that Hornby used, because theirs has actually got a model number down the side. This is one that was bought for about £1.50, £1.60 on eBay. I bought 3 of these to have a play around with, knowing that the motors in the early TT models are problematic. I've had several now that have failed. I do run my locos quite a bit. If they settle down and run okay, 30 hours to 34, 35 hours seems to be the service life of this style of motor. So this one has it's a slightly different, it's got a longer spindle coming out at the rear. That's not necessarily a problem to do a full swap. As I say, on another loco, rather than send it back to Hornby, I did a little bit of investigation myself, and I took off, this is the end cap. So this is the section that holds the bushes. It has a small bearing in here, and it also has the electrical contacts that they feed from the decoder to the motor that feed it to. On these motors, there is a positive always marked as well. It's important to get that the right way around, so that when you put your loco back on the track, forwards is still the forwards it was intended to be. So this is what actually occurs. You'll see that instead of having carbon brushes, it has these small fingers here. And if you look, you'll see there's the remains of one just poking here, and the other 2 have snapped off completely. They haven't actually snapped. What they've done is they've burnt through, and that's what happens on these. They burn out, and invariably it will be on the positive terminal that they suffer this fate. If you look, the negative contact or brush, for want of a better word, is slightly different. It has this section on here as well, and these are still in place. These aren't available as a service replacement item, like many things now, particularly with electronics. There's no serviceable components. But what I did was I actually removed from the type of motor I just showed you earlier the complete brush assembly. And the reason why I did that, I wanted to see how well it would work just by renewing the brushes. If you swap the motor, the one thing you will find straight away is you will need to remove the worm gear, which is the little brass device that goes on the end of here that can transmit the power to the radial gears that are fitted in the loco. So without doing that, because that's a little bit more complicated for people, you just simply bend the little tabs back on here. You can pull out the end cap. You do the same on the motor that you're replacing it on, and then you can just carefully slide that in. But this time what I'm going to do is I'm going to fit an entire motor. But what I will do is, the plan is I'll open up the new one that was fitted in here and just see if there's anything visible that's going on. Certainly with the noises it's making, it doesn't sound, it's like it's very happy. And I have a feeling that we're going to see broken fingers in there already, which means that it's been delivered from the suppliers to Hornby in a failed state, which is obviously a little bit concerning as well. Okay, so things you will need to get the body off one of these. Before I do that, I'm actually going to show you another one. There is another motor solution which is available as well. This is a coreless motor. This one's made by Micromotor. You will see that the motor itself is referred to as a bell armature because basically the insides are quite different. So it runs in a different way, and you get a 3D printed case which you end up gluing on just with a bit of super glue. You use this to help position, and that's basically going to make up the same dimensions. Now there are a couple of other very well respected people in the hobby who I've asked, and they are actually looking at some kits as well, alternative kits, so there'll be a choice again for those of us who want to upgrade or do home repairs and things like that. And so if I get any word back on there, obviously I will advise people. As always, I only recommend stuff that I find good or works. I never ask anybody for any money, and I always pay for all of my goods and things like that, because I find then I don't have to say to somebody, oh, it's really good, when I'm thinking, that's not so clever. Right, okay, further ado, let's get into taking the body off. Now on an A4 you will need one of these. This is a nut spinner. This is available as a part from Hornby, and the reason being that on an A4, unlike the A1 and A3s, it has what's called a mechanical lubricator, which is this section here On the real locomotive, as it wheels went round, this would be pumping the lubrication, and so it would be providing lubrication to all the axles and the wheel bearings. This is the only part that is fixed to the body. All of the other linkage is attached to the chassis. So in order to remove the body, you will need to remove it. And what you're looking to do is the connecting rod nut. You just simply unscrew it. You'll find that it'll probably stay in as you do it, and then you can just carefully lift it. When you take it out, if you're not quite sure, take a photograph so you get the orientation correct for when you refit it. It has got a couple of flats on the inside. They are very small, but they are just about visible. So you can remove that. I am actually going to put the screw back in because my intention is I'll run this as a chassis alone with no body on, so you can so we can test it. So that's the screw back in place. It's not going to get lost, and that's out of the way. The next thing we need to do is to I'm going to remove the tender because I'm going to be doing some soldering. I'd always advise that never have other electrics attached if you're going to be soldering. It's always good practice not to. So to remove the tender, you simply need to remove this pivot screw. Not quite enough yet. Hopefully there is sufficient light. It's a bit of a fiddly thing. Right, so screw is out. That bar is now released, and the next thing to do is to remove the 4-pin connector, this little white block here. Now you can get a proper tool from Hornby for removing this, however it is designed for their 00 models, and you'll find that it won't fit on the TT ones because the block is hard up against the moulding here. So I find a cranked set of tweezers, these are so useful. There are some edges down here, and you can just get the edge in and tease it out. It's important that you do not pull on those wires because you will separate them from the terminals on the inside, and then you're just going to set yourself up for more problems. So we've now removed the plug of the tender, so the next thing to do is to remove the front bogie. And of course we all know they can be good fun as well. However, you'll see I've made modifications to my front bogie on here. I've just removed the wheel lines completely, and that enables these to run absolutely fine. So it is a Phillips screw in here. Sometimes you'll find with these Phillips screws that the depth of them isn't really quite right, so you're using a flat blade, but a small one can help get those out a bit easier. So I'm just going to lift out the bogie. And then there's this other screw here. This might, on some models, be covered with a piece of insulation tape, which was fitted in the factory, and I believe that was potentially to stop an issue of shorting across here. But that, if anything, seems to be, and it was said right at the beginning that it shouldn't have been there, and for some people it has actually created a running problem, although I find it's actually the moulding on the front of the bogie that would catch in here. Also getting the gauging right as well. There's a whole load of little trims, and I know some people are going to say, oh, you shouldn't need to do this on a ready to run model, but you know, these are very fine detailed models, and sometimes if people mishandle them, they can, unbeknown to themselves, start sort of getting things misaligned, and that's why they don't run so well. So now we've removed the screws. The screw that holds the tender drawbar in also secures to the bodywork. There's a little brass insert inside there, and this one goes through into the bodywork of the loco. So those are the two screws that hold everything, the chassis to the body. To remove those, I again, with my crank, just pull that up there. It's going to be a tighter fit here where this this valance part is, and then if you remove this, you'll notice it just pulls away there. So that's the body off. Now this is where the motor is. I'm going to flip it around so you can see Hornby have this code Q382H, and that is the type of motor that's fitted to the A1, A3, A4 Pacifics and the 08 shunter. It's notable that when there was a recent conversation over the launch of the J50 tank, which is due later this year, Carl from Hornby was keen to point out that that 3-pole motor would be coming with traditional style carbon brushes. So that is a departure from these, which makes me think they are aware. Also, there is the other point that the 5-pole motors are fitted in things like the Duchess, the HSTs and the Class 50s. They have a 5-pole skew wound motor. From what I've seen, they also have this style of precious metal finger contacts in. However, not any experience of the longevity. It is a completely different motor though, much bigger. So hopefully that will be a more practical solution. So to remove the motor, it's quite easy. You've got 3 screws here, and these hold the motor mount on top, and then you've got the gearbox section underneath. Again, I'm just going to use that in there. Do be careful when you're unscrewing things and make sure you don't lose the screws, because that will be a real pain. They do pretty much need most of them. Oops. Now you'll notice I'm doing this on a piece of cloth rather than in a cradle. I find that actually this can work really well. One piece of white cloth, it's really easy to see where all the screws and everything are. It also tends to hold things and stop things from rolling away rather than having it on the cutting mat. So we've got those screws there. Again, if you're not familiar with the size of screws, where they go, do be aware some screws are bigger and, or rather longer and shorter than others, so make sure you get them in the right order. And then to remove the motor mount, it just comes out like that. Now earlier you'll remember I said about a brass worm gear, and that's the brass worm gear here. Now that is removable, but you will need special tools to do it. Something which is available, and when I got this one from Tramfabrique, it was actually getting this when I noticed that they did the little lights, which I did a video on putting those in. So this is a gear puller, and you get a series of small inserts here, and what happens is that pushes down on the shaft. This pulling bar is at the back of the motor, between the motor and the worm gear, and as you drive it in, that will pull it off. This is an interference fit, so it's going to be quite hard, and to get the shaft in you need a very thin shaft. You'll see these have been turned down to, I think it's 0.9 of a millimetre, because it's a 1mm shaft. At this length you run the risk of breaking it, so you do need to take some precautions. One, I'm actually going to measure this to see how much I can cut this down by, so that it's going to be as short as it just needs to be. And the other thing is I'm actually going to heat this brass worm so that it can be removed easily. But before you do that, you will need to measure the dimensions of where the worm fits on the shaft, so that when the motor is located in this section here, the worm gear will engage fully and correctly with the shaft, I say rather with the gear on here. Okay, so now one thing I'm actually just going to check is to make sure that when this is in place that it is meshing properly, because that is a thing that could make a lot of noise. Now there does seem to be some rocking, so I'm going to pop the, I'm not going to screw it down this time, I'm just going to make sure that that is holding correctly. I mean, this wouldn't affect the maximum speed it run at, but it certainly could cause it to make noise. Now it appears to have the right amount of engagement. You'll notice that there are gaps, and they are intended, that's backlash. If you didn't have that on any gears, they would just bind up. So there needs to be a degree of backlash in it, and that is absolutely fine. There's no broken teeth on the gears. If I pull this away, the mechanism runs nicely. No broken teeth, there's no wear marks. So the actual plastic gears seem to be quite, well, they seem to be perfect. Again, there's no drag in any of the mechanisms, so it's not caused by anything being distorted here. So the next thing to do is to remove the motor. Now, one thing which you'll notice, it's got this little bit of tape on here. I was a bit disappointed, really, I have to say. When this was returned back from Hornby, there was no... I've actually had this off before because I was curious to see whether they put the same motor in or they did something else. Basically the insulation that should sit over here and here was left off, which when you have the motor mount in place, obviously gives an opportunity for that to touch. There is an increased possibility of a short. I know this motor didn't suffer that because I put something on, but now I'm removing this motor. I'll actually put something back on when I come to refit it. So the next thing to do is, okay, so I've got my soldering iron set up, and the next thing I'm going to do is I'm actually going to mark the positive wire so I know which one to attach to the positive terminal on the motor. You do exactly the same if you're going to do a brush swap as well. So I've already checked, that's the one with the positive on, and I'm going to pop a little red marker on there. I'm also going to do it a little bit further down on a couple of places, just in case I wipe it off. These little paint pens are absolutely fantastic. They're really useful for all sorts of modelling jobs, even if you're things like applying red lining to rolling stock, etc. Right, get the. I'm going to remove the positive one first. There we go. That's it off there, and that's it off there. Right, so that's now the motor is now detached. It does have this little bit of foam insulation, or rather that's actually a piece of padding, so that's something to think about when we're actually reinstating this different motor to make sure that that is going to sit correctly. Now you'll see these motors described as N20. The thing to remember with that purely means the physical dimensions of the body here. It doesn't have any bearing on the quality of the internals, and also these are available at different voltage ratings, so you need these to be running. Sometimes they're described as 6 and 12 volt. Basically they start running around about 3 volts, and so that's the start voltage to get them running. So when you're getting them, do be aware N20 doesn't mean it's going to be exactly the same as this. These could have been intended as being very high quality. I don't know, they don't seem to last very long. One of the problems is that this type of motor has some fantastic properties. It's very quiet, it has very low voltage, or rather current draw, not voltage. It also has a couple of disadvantages, as in it prefers to run at a constant speed. It also prefers to run forwards and not be stopped frequently or run in reverse, which is a problem on model railways because most people will be stopping and starting their locos, and they will also be running in reverse as well. So the first thing we're going to do before we even think about opening the end is I do want to record some dimensions so that I know exactly where this needs to fit so that it engages fully on the gears there. So I'm going to get myself a piece of paper and I'm going to write it down rather than try and remember. So here we are back on the table, and just going to show you, first of all, this is the type of motor. This is not an exact one that Hornby used, because theirs actually has got a model number down the side. This is one that was bought for about £1.50, £1.60 on eBay. I bought 3 of these to have a play around with, knowing that the motors in the early TT models are problematic. I've had several now that have failed. I do run my locos quite a bit. If they settle down and run okay, 30 hours to 34, 35 hours seems to be the service life of this style of motor. So this one has it's a slightly different, it's got a longer spindle coming out at the rear. That's not necessarily a problem to do a full swap. As I say, on another loco, rather than send it back to Hornby, I did a little bit of investigation myself, and I took off, this is the end cap. So this is the section that holds the bushes. It has a small bearing in here, and it also has the electrical contacts that they feed from the decoder to the motor that feed it to. On these motors, there is a positive always marked as well. It's important to get that the right way around, so that when you put your loco back on the track, forwards is still the forwards it was intended to be. So this is what actually occurs. You'll see that instead of having carbon brushes, it has these small fingers here. And if you look, you'll see there's the remains of one just poking here, and the other 2 have snapped off completely. They haven't actually snapped. What they've done is they've burnt through, and that's what happens on these. They burn out, and invariably it will be on the positive terminal that they suffer this fate. If you look, the negative contact or brush, for want of a better word, is slightly different. It has this section on here as well, and these are still in place. These aren't available as a service replacement item, like many things now, particularly with electronics. There's no serviceable components. But what I did was I actually removed from the type of motor I just showed you earlier the complete brush assembly. And the reason why I did that, I wanted to see how well it would work just by renewing the brushes. If you swap the motor, the one thing you will find straight away is you will need to remove the worm gear, which is the little brass device that goes on the end of here that can transmit the power to the radial gears that are fitted in the loco. So without doing that, because that's a little bit more complicated for people, you just simply bend the little tabs back on here. You can pull out the end cap. You do the same on the motor that you're replacing it on, and then you can just carefully slide that in. But this time what I'm going to do is I'm going to fit an entire motor. But what I will do is, the plan is I'll open up the new one that was fitted in here and just see if there's anything visible that's going on. Certainly with the noises it's making, it doesn't sound, it's like it's very happy. And I have a feeling that we're going to see broken fingers in there already, which means that it's been delivered from the suppliers to Hornby in a failed state, which is obviously a little bit concerning as well. Okay, so things you will need to get the body off one of these. Before I do that, I'm actually going to show you another one. There is another motor solution which is available as well. This is a coreless motor. This one's made by Micromotor. You will see that the motor itself is referred to as a bell armature because basically the insides are quite different. So it runs in a different way, and you get a 3D printed case which you end up gluing on just with a bit of super glue. You use this to help position, and that's basically going to make up the same dimensions. Now there are a couple of other very well respected people in the hobby who I've asked, and they are actually looking at some kits as well, alternative kits, so there'll be a choice again for those of us who want to upgrade or do home repairs and things like that. And so if I get any word back on there, obviously I will advise people. As always, I only recommend stuff that I find good or works. I never ask anybody for any money, and I always pay for all of my goods and things like that, because I find then I don't have to say to somebody, oh, it's really good, when I'm thinking, that's not so clever. Right, okay, further ado, let's get into taking the body off. Now on an A4, you will need one of these. This is a nut spinner. This is available as a part from Hornby, and the reason being that on an A4, unlike the A1 and A3s, it has what's called a mechanical lubricator, which is this section. Okay, so I'll pop the motor into just a helping hand, just because I don't really fancy burning myself. Okay, so I'm going to spark up my soldering iron, and I'm just going to give this a little bit of heat. Hopefully you can see. Anything that's burning off, well, that'll just be lubricant. You don't need to heat for too long. The thermal expansion rate of brass versus steel is much greater. In other words, it moves further for a given amount of temperature. Don't worry about necessarily damaging the brass. It might discolour slightly. Sorry, I'm holding it out because I'm trying to see what I'm doing. That should be about enough. Brass has a melting point of 900 degrees centigrade, and even with this, with that amount of heat in it, it's not going to be anywhere near that. Right, now then, this is going to be a bit more difficult because I'm trying to do it so you can see, but critically so I can see, because I don't want to get this wrong. I'm going to assemble this over here. I'll try and do it before we get too much cooling. You can see why film crews are so complicated. Right. Going to pop that on there. I'm actually going to hold it via. Now I've got to take that out because I should be able to just hold it on bits I know are cold. And round we go. Oh, and that has bent that double. Hello, right, okay, apologies for the slight break in coverage there. It was getting very tricky. Then the gardener started cutting the lawns with his infernal machine. So rather than lose the temperature, I pressed on. Now, something which I discovered, the pin, even with heat, will break if you try using it at its full length. And that was something we wanted to try out. Sven asked me if I would actually try it and see what happened. However, what you can do is, to prevent it from breaking, if you nip off, which you can do with a standard set of side cutters, if you take that amount off, and then using this short pin to drive in to begin with, you can, even with some heat in there, that's what you're going to have to do, and it's just going to start the shaft moving sufficiently, but there's not too much pressure on here. Bear in mind, you are probably going to bend these, so do get some spares. It's well worth it. Once you've got it to move, of course, then this is going to bottom out, but the brass worm is not going to be sufficiently off. So then what you're going to do is revert to the regular length one, which is going to give you sufficient penetration in there to allow it to come off. So if there's any questions or anything like that, ask me. If I say, it's a bit tricky because when you're trying to balance a camera and there's a load of other things going on as well. But my advice is, certainly with these pins, they are so fragile. I mean, I did half expect it, which is why I got extras. You can see I've actually taken possibly 2-3 millimeters off the end there. And that, I say, that's what happens if you don't. So don't bother wasting one doing it. I've done that bit for you. So this is the original motor. This has actually come off. The next thing we're going to do is I'm going to reinstate this onto the shaft here, and then we're going to use the pullers to work in reverse. And so and then we'll set that to the same distance, resolder, put some packing on there. The heat did make short work of that little bit of foam. That's all kind of shriveled up there, but we'll make something else to go in there. But I am very curious. Let's have a look and see if we can see what was going on with this motor, and see if it was a very similar thing to what's happened before. So just using a screwdriver, and if you are going to just replace the brushes, this is a bit that'll be interesting for you. So take a very small flat blade screwdriver and try and get that into the end and just prise this up. Be careful because you don't want to overbend it, because we want to use this again, this little tab. This one's not quite as far down. And once you've got enough clearance, we should be able to just prise this apart. We're going to have a look. Well, I'm going to say, in terms of the quality of the, yeah, it's marking up already. So let's have a little look. This time it's on the negative ones. There's a definite marking going on these. Might be too small to see. On the other one, I bent the fingers up out of the way, so it was going to show up clearer. I don't think we're going to be able to get it. Not quite got microscope quality on an iPhone yet. But it looks like it's leaving a deposit on one of the center fingers. So that was the the standard Hornby one that was fitted under warranty. I say I'm not out doing this for any kind of blame game. It is what it is. But what we're going to do next is install the worm drive on here and see if we can get this loco going again. Okay, so to install the worm gear, the first thing I've done is made sure it's on the rotor end, and then I've just pushed it and then pressed it down, and that's got me part of the way. It has actually started to go. Now, I'm sure this wasn't intended, but something which I've just found which can help is this will actually pop inside here. We can use the larger forks on here and push that in, and that is going to provide a support. In fact, I might be able to do it on the other ones. So that's going to, yeah, it does need to be the larger ones. So using these, we've got that acting on the back. Now, you don't need very much pressure at all, and then we should get this centralized. You have to get just enough thread on here, and then we can start to just push this in. So that's the thread into there. Might be easy to do the threaded section first, and then we can just gently apply a couple of threads at a time and then measure. I've actually preset my vernier caliper to the measurement that I had previously. I'm going to just double check that that is up against it. Yep. So I've now actually got that set to 11. Oh, I could do with a little bit more. So I'm going to go a bit further with that. So just in this case, the way I found it can work, get one thread on, pop this in, slide the plate at the back on, you do have to be careful that you don't compress anything and squash any vital bits. Add possibly a half turn and measure again. Yep, so we're now set at the same distance as before. So the remaining thing to do now is to solder the terminals back on, reinstate the motor, add some packing on there. We should be good to go. Just to give you an idea, even though that shaft is slightly longer, I can see we're just not quite sure. You can just hold the motor up against this and check that it runs and engages fully. As I say, there's sufficient backlash in these that it should work without too much problem. You've got to be quite a long way out before you end up with it starting to bind. Right, a slurp of tea and we shall move on. Okay, so first of all, I've popped some flux just on the terminals of the motor here, and then just going to get a bit of heat on there and just a little blob of solder. this is basically tinning the contacts, which is going to make it a whole lot easier getting the wires on. Right, first of all we need to identify which is the positive. I think actually holding the motor in the chassis might actually be the easiest way. So my tweezers, just now going to give that little, always make sure the tip of your soldering iron is clean and has a little bit of solder on. That helps the heat. Whoop, what have I forgotten? Well, I forgot what Hornby forgot. We're going to pop a little piece of heat shrink on. I think easy done. No one's perfect. Right, let's go again. Yep, okay. Let's give it a little thing. Let's just check. Yep, so I've got the red wire on. Actually, using the chassis to hold the motor is a useful little tip. Just going to bring that bit of heat shrink over there so it's out of the way. Just going to use the heat of the iron just to get that to shrink down onto there. And then same again. Apologies for the cough there. I had this horrible cold bug thing going on. I've nearly done it again. I bet the bloke at Hornby that forgot to put the heat shrink on was chatting into a camera, doing a YouTube video. That'd be what it was. So here we go. So that's on there. Just get some heat on that heat shrink. Just really want it to grip on that end. As much as anything, it's just to provide some insulation against the metal chassis. I mean, it's one of those things, it might never, ever, ever come in contact. But then it might. Always best to mitigate against these things if possible. Right, so that's actually the hopefully the hard bit done. So the next thing I'm going to do is I'm going to fit the top motor mount on. Now I moved all my bits and pieces out of the way, but hopefully everything should be okay. That's all going to fit on there. I am actually going to put some lubricant on here because now that's going to be dry as a bone. So I shall go and get that. And back again. Here we go. So just going to put a few drops of lubricant on, because remember when we got all the heat in there, that burnt off any kind of lubricant that there was going on. Not going to put too much on. I'm just going to run that in. It will of course be something. If you wonder where this came from, I picked this one up from Peter Spares, who does a lot of parts for various different models. Right, and now we are, next stage is to reinstate sufficient that we can test. So I know that it's these longer screws. When you're putting things like this down, just get stuff engaged to begin with. Don't go tightening it up fully on one screw. You want to try and get it done evenly. Now I've put that in without any packing on there. I just wanted to just see if it does make any kind of difference, or whether it's just one of those things that's been it could be that even the application of that motor has it already fitted and it's just not necessary here. So just a little bit of finger pressure on the mount, just gently bring up the tightness of the screws. Just go around, cycle them around. I'm just going to have a quick look and see. Well, there is a little bit of movement, so that could actually be noisy. So I think it might be worth putting something in. So I'm now going to search out a suitable piece of packing, which I think is going to look an awful lot like insulation tape. Well, it's not it's not insulation tape, it's helicopter tape, because of course it's the kind of thing everybody has lying around. It's what you put on the edges of the rotor blades to stop them getting damaged. Got to keep your kite flying. So it's quite it's incredibly durable, this stuff, and it's great if you've got a bicycle, because you put it down the down tube, or on cars on front spoilers and things like that. So it's a little bit thicker, but it's insulating, and also when it's on there and that's going to be in, that's going to hold that nicely. I'm sure you could make something suitable with, say, some insulation tape and a couple of layers of it, but so you just have to have this. So same again, I'm going to try it and see how it is. You really are getting this real time, so I'll leave all the bits in, warts and all. You can often see that, so this is, I'm doing this the first time along with you guys, so you can see exactly how it's going together. And sometimes also, if you can see things when people don't quite get it right, it does help. We learn more from mistakes than we do from getting things right, as a great engineer once said. Let's have a look. That's nice and secure, so we shouldn't get a lot of motor vibration, and critically it shouldn't wobble around, so it should keep it nice and secured. I know that the mesh on the gears is all fine, so that's all going to be good there. So the next thing to do is I'm just going to hook this up to the tender, and then we'll get this onto the layout, and we'll see if this work has actually been successful. And if it hasn't, this video won't see the light of day, because there'll be no point to it. So just carefully, maybe do it this way around because I am right-handed. Just going to line the plug up and gently push it in home. Excuse me, as I was saying, I've had this horrific cold thing. Either that or it's Ebola or something. There's a lot of it around. So, the next thing to do is get this on the layout. I will actually pop something down as well to act as a little drawbar retainer, because I don't like this just rattling loose, because it just pulls on the wires. Sometimes if you ever have connection problems, just make sure that these female pins are seated home correctly as well, even though they're held in the plastic block there. Right, to the layout. So here we are, I've popped it on. I thought just for fun, I've used one of the little pins that I bent, and that's actually acting as the drawbar retainer. So here's the big moment. Right, let's get some power on. Just fire up the... There we go. Right, and put the address in for Silver King. Obviously going to run it without sound. Here's the big moment. Does it work? Yep. That's crawling well. Actually, that's very smooth. Just going to... Now the big test is, does it get up to something like a reasonable speed? So I don't normally run locos at their maximum speed. Sorry, I've got this on the tripod and there we go. Well, that's what I would say is the too fast speed that I would expect on a loco before you've fine-tuned it and set it, so you can drop it back from there. Yep. Now the big test was, is it going to grind like an old steam hammer or something in reverse? Well, this seems to be equally as smooth as it was going forwards, which I'm sorry, Hornby, that's better than yours. What noise does it make when it stops? None. Okay, well, I'm going to call that a success. The next thing to do will be to run this and see how long it lasts. So these motors are a mere £1.50, 60. I think they list them for a whole range of applications, everything from slot car racing cars to inkjet printers and things like that run all, not inkjets, the other ones. Anyway, so next thing to do is to pop the body back on and just keep running it. So I'll keep you updated to how this works. Any questions, bob them down below. I'll leave a couple of links in the comments section regarding all the bits and pieces that I've used. Hopefully people at Hornby see this and say, well, look, there is something you can make better. So right now, this is running better than the original equipment one. I would say it probably, in fairness, is equal to the standard of the motor that when this loco was new, because this was one of my best running loco until I got a Duchess. And I say I've made changes on all of them and got them better. Just so you know, I did spend about nearly 3 days with the DCC app making a whole raft of minute changes to see if that original motor could be made to run better, and what you saw was the very best it could run. And all I've done this time, as you've seen right before your eyes, fitted this different motor. It's run on exactly the same profile, no changes to CVs, and that's the difference. It's chalk and cheese. So these are fixable. Long term, say, we don't know how long this is going to stay as good as it is now, but we can only hope. And right, so thank you very much for watching. If you've made it this long, I did warn you it was going to be a long one, but you've got it, warts and all. Please do share, like and subscribe so that more people get to see the things we're doing. I say there's no money involved in this. This is purely because of the fact that like most of us, we want the hobby to move forward, and we all try and share and like each other's content, no matter what scale you're operating in. So don't be a TT120 hater, and keep safe and happy modelling.